welcome to today's session. My name is Benoit Fillion. I am the founder of Laboratoire Optim, and I'm happy to moderate this webinar today. I'd like to introduce you today to our presenter, Maria Eugenia. She is a nutritionist and co-founder of Elie Health Solutions. She is joining us from Cadiz, Spain today. Maria Eugenia has worked for many years as a practitioner, but also as a scientist in the field of microbiota. She's currently working on postbiotic substances and their impact on health. We also have David Manrique joining us today from Sevilla, Spain. David is also the co-founder of Elie Health Solutions. He is trained as a pharmacist and has over 10 years experience in microbiota. David will join us in the Q&A session after the presentation. A recorded version of this webinar will be available so that you can watch it again. And you will receive shortly after the presentation or the webinar, the link to access the video. You can ask all your questions through the webinar interface. And we will take time after the presentation to answer all of your questions. So now I'd like to let Maria Eugenia talk about short-chain fatty acids and their role on the microbiota.
Okay, so yeah, thank you, Benoit, for the introduction and the organization of the webinar. This incredible tool, so useful nowadays. And yeah, so the webinar is called Short-Chain Fatty Acid, mainly butyrate, what we're talking about today, and human gut microbiota. First of all, I would like to talk about different fatty acids to make sure we know like where butyric acid or butyrate would be. So we are more used to hear about long chain fatty acids like DHA or EPA, and also medium chain fatty acids like caprylic, capric, or caproic. But today we were talking about short chain fatty acid like butyrate, butyric acid, which has only 4 carbon atoms. And there are also other short chain fatty acids like propionate or acetate, but today we're going to be talking especially about butyrate. So in food where we can find butyrate is mainly in butter where we can find it. And actually the name butter comes from the Latin butyrum. So that's a curiosity about the name of butter, but also to talk about the content of butyrate in the butter, which is around 3 or 4% on butter. But this butyrate that is contained in butter is in a form of a butyrate triglyceride, is in a form of a tributyrin. And when butter is getting old, like it's getting spoiled or it is gone bad, after the expiration date of the butter, this rancid smell that is typical in this situation, the substance responsible for this smell would be the butyric acid, the free butyric acid that is appearing when this triglyceride is getting it's past the expiration date. Also, is nowadays very famous the use of ghee. I don't know if you're aware of this product. They're quite fashionable nowadays. Is some type of product related to butter, especially it's called clarified butter or ghee. That is very it's been used for centuries in the Indian culture and the Ayurvedic medicine. Also, there's another way where we can get butyric acid and that is the fermentation of fiber in the colon. So different foods contain different types of fiber, and depending on several factors like solubility, on even digestive motility, and of the host, we would have different fermentability degrees of this fiber. And we will talk about during this webinar about how this fiber is fermented in the colon, and that is why butyrate is produced in the intestinal lumen. So I'd like to remind the concepts that they're very well known by everyone, but just to make an introduction also on the postbiotic concepts. So this for many years we've been seeing and hearing about and reading about prebiotics, like this fiber, this specialized fiber that has beneficial influence when the microbiota is fermenting them. So a prebiotic actually means promoter of life. So they are fermented by gut microbiota, by this probiotics we all know about, like live microorganisms that provide health benefits. And by the interaction of these two, we would have the postbiotic we're talking about today, especially about the production of short-chain fatty acids like butyrate. So prebiotic would be the food, let's call it, for the probiotics. So they will support the probiotic growth and their activity. And then this postbiotic would be the molecules that are produced by this interaction, and they mimic the function or the activity. They're mainly responsible for the activity of the probiotic. So for many years we've seen in the market prebiotics and probiotics. They would be like the first generation of products that were designed to make an influence on the gut microbiota and the health of the consumer. And now we'll have nowadays like a second generation of this kind of products, considered postbiotic, that are natural molecules from probiotics that confer a health benefit to the consumer. So this would be a representation of resistant starch, a type of fiber in the gut that is being fermented by some genera of bacteria, and you have like a rain, like some drops that are produced by this interaction. But this process is not a simple process. This process of fermentation is a complex and cross-feeding process where we have some primary degraders are called, so genera of bacteria that are doing these primary stages of the fermentation, and then there are other called secondary degraders that would continue this fermentation process in these different pathways for the short-chain fatty acids biosynthesis. This is coming from the carbohydrate fermentation, the fermentation of this fiber. So short-chain fatty acids like propionate or acetate can be produced in these primary stages, but then butyrate, for example, needs a lot more complex pathways to be produced. So here in this representation from T0 video, you can see these other secondary degraders, these other genera of bacteria, and how they also interact and they act in this fermentation process, producing this called short-chain fatty acids. But also, it's important to see that there are not only fibers are considered prebiotics, or not only fiber can have this promotion of life, let's call it, action. There are other substances, for example, pea protein, this plant protein from pea, that has this prebiotic effect by increasing some general bacteria that are butyrate producer or short chain fatty acids producers. So this is not only fiber, there are other substances that can do this same effect in the gut. So these little drops would be the short chain fatty acids produced in this fermentation process. And in this representation, so we have the probiotics that are producing this postbiotics molecule, and how these molecules that are produced locally are produced in the intestinal lumen. They are where they are being specifically used. So this is a very intelligent, very smart process, because this butyrate is produced where it's needed. The intestinal cell area is very large, and the amount of cells is very large, and the amount of nutrient to feed these cells is also large. So biologically, this is a smart process, a very intelligent process, where butyrate is produced where it's needed. So in this representation, you can see how the butyrate is being produced locally where it's needed to feed the enterocytes. So the enterocytes are fed mainly by butyrate. It's their favorite nutrient, and every time that it's available, it's going to be the fuel for the enterocytes. So regarding its function, the functions of butyrate, they are mainly to increase the mucus production. Remember that the mucus layer in the gut is where the microbiota, the gut microbiota live. So that's one of the key and most important action of butyrates, to increase the mucus production. Also to decrease the cell permeability by promoting tight junctions between the enterocytes, and also to decrease the pH in the intestinal lumen, thing we're going to talk about in a while. So yeah, this is regarding the action that happens in the intestinal lumen because of the butyrate action. One of them is the effect on constipation, on how the production of butyrate can, by lowering the pH, by also promoting changes in the microbiome, to accelerate the transit time, and that can be beneficial for some consumers with constipation. Also, it is remarkable to see how in this fermentation also gas is being produced. So that's why some people will suffer from bloating or flatulence when they ingest certain amount of fiber and certain types of it. So yeah, so this would be a representation of on the left of a healthy gut with a mucus layer, with a thick mucus layer, with in this representation we can see like a good cellular differentiation, where several globule cells they are responsible for the mucus production. So we see here this thick layer of mucus containing diverse microbial ecology. And also it is represented, the cells are represented like very close one to another. So as is shown as low permeability status, high impermeability status. So this would be like a healthy, normal gut barrier with health function. And then on the other representation, they show, like, you can see the cells are not close to one another. So this, and they also represent very few global cells with a very thin layer of mucus and a low diverse microbiota. Also, the cells are not well together to one another, so this is representing a high permeability status. And also these cells, some of the cells are represented like a broken cells, like an apoptotic cells, like this one. So some authors consider butyrate as a postbiotic, obviously, but also as a prebiotic. And that is why we've been speaking so far about the effect of butyrate in the intestinal wall and how the butyrate is nourishing this wall for a good functioning, to have a good function. But also, apparently, the presence of butyrate in the intestinal lumen is what it does is also increases the short chain fatty acid producing bacteria. So that's why they are considering this substance not only a postbiotic but also a prebiotic, like a promoter of life in the gut lumen. And also, apparently, these butyrate molecules can decrease the endotoxin secreting bacteria, and for that reason to decrease the endotoxin like LPS in the intestinal lumen. So yeah, in a health situation, here we would have how the short chain fatty acids keep this tight junction between the cells intact. And that's how a normal transport of molecule through the intestinal wall will happen, with both transcellular and paracellular transport happening normally. But also they represent how a broken tight junction can lead to inflammation, to a heightened immune response, because this would lead to a translocation of large and indigested molecules or bacteria that can lead to several conditions like allergic reactions, intolerance, diarrhea, etc. So there are many like pollution, for example, or pathogens, infections, also the genetic susceptibility, and especially diet, low fiber diet, typical Western diet, etc. So this altered microbiota would make an influence on the epithelial gut layer by damaging it, and for that reason and haters immune response, which may lead to different inflammatory conditions. So related to diet, we would have two concepts with authors speak a lot. The eubiosis would be this situation where short chain fatty acids are produced, and the microbial is very diverse in the microbiota. And then we have this other concept with the dysbiosis, where this short chain fatty acids producing bacteria are not so active. They are not producing enough short chain fatty acids, and the microbial diversity is going low. And these two status are, some authors related them to the type of diet that someone can follow, or let's call it that the diet you have, it has an influence on the microbiota you may have as well. So a Mediterranean style diet rich in fresh food, full of fiber and this type of ingredient would lead to to this healthier status of the gut microbiota. And in opposition, we would have this Western typical diet with a very low density nutrient diet, and this low quantity in fibers, etc., that would lead to this other dysbiosis situation. There's this article where they show how a fiber-rich diet would lead to this thick mucus layer and this diverse microbiota. And on the other hand, we have this fiber-free diet they're feeding the mouse with. And apparently what happens is, because this mucus layer is the house of the gut bacteria, it's their environment. If they don't have nutrients to be fed with, if they don't have fiber for them to act as a prebiotic and for them to use it as a fuel, what would have happened, it would be that this bacteria would eat the mucus layer, destroying it and destroying the epithelium. So it's kind of a message that we should feed our gut microbiota, or they would eat us alive, or something like that. So in this situation, we have what we call a vicious circle, where a dysbiosis is happening. And this dysbiosis is conditioning a decreased butyric acid production. And also this low butyric production is, as we have seen before, is conditioning an status of where the permeability of the gut is increased. And for that reason, some chronic inflammation, low-grade inflammation can happen. And this is conditioning, again, status of dysbiosis. So there are different strategies we can follow from many years. We've been seeing the use of probiotics and prebiotics to try to fight this dysbiosis, and also to try for this bacteria through fermentation to increase the butyric production. Now we have this postbiotic second generation of products that we can make an influence on the butyric production by supplementing it, by making a direct effect on this and on this point of the vicious circle. And maybe with this complementary strategies, we can try to break it. So we call this this intervention on the gut, we call it the 3 Ps. So we have the prebiotics first stage, then we have the probiotics, and then as a novelty, we have this postbiotics. Postbiotics are considered like the new frontier in the microbiome science. There are these compounds produced by the activity of probiotic bacteria, and also they are produced when bacteria digest and ferment foods, as we've seen, and also this microbiome ecosystem the microbiome ecosystem consists of both probiotic bacteria that is producing postbiotic metabolites. We can claim their action by these metabolites. So the thing is this probiotic bacteria are important because what they do, not because who they are or where they are, but for what they do. And what they do is they produce these metabolites, this molecule called postbiotics, that they represent the probiotic evolution. Because they're safer, there are no harmful bacteria components. Also, there's no need for the bacteria to do anything really. so you don't need to wait for a bacterial growth or a bacteria colonization, because you can use the postbiotic, these molecules, you can use them directly. And also it's easier to manage the dosage. You can at least easier than when you work with probiotics. With postbiotics, it's easier to have higher concentration of the molecules you are looking for. So we've been talking about the relationship of butyrate in the gut microbiota in the intestinal lumen would be here. So this how it's influencing the microbial ecology as a postbiotic, as a prebiotic we've seen. Then also we've seen how butyrate is the main source of energy, is the main fuel for the epithelial cell, for the enterocytes. So this would add locally 85% of the butyrate produced in the intestinal gut would remain feeding the enterocytes. But also, there are many other studies, they're newer, that talk about how also butyrate has an impact not only on the gut microbiota, not only feeding the enterocytes and making a functional gut barrier, but also into a systemic level. You can now see articles talking about the gut brain axis, the gut muscle axis, the gut heart axis, or the gut bone axis, for example, many others. So in all these articles, butyrate has a very important role, and there are many signs to come in these systemic actions of butyrate. Here, I'll leave you some of the reference for you to check on them, as you will have the presentation. And also, yeah, there are many studies relating for example, to the use of butyrate on the intestinal injury associated with the use of antibiotics. And also you can find more studies on the enteral nutrition, of the enteral use of different forms of butyrates by feeding tube in more severe patients. So yeah, in this study, you can also find how the authors consider that the use of the supplements with butyrate can be very helpful to many diseases, like, for example, IBS, and also how different formulation of butyrate can work in these aspects, where the limitation of organoleptic characteristic is very important. So for this development of products, what it is very important are three things. One of them, obviously, is dosage. For have a product in a daily dose that match the purpose of the consumer, and secondary, it is very important that the product has a delivery technology. Why is that? Because as we've seen, butyrate is produced in the intestinal lumen, in the colon gap, in the colon. So what we need is where the product has the technology to make sure that the delivery of the butyrate is done in the place where it's needed, in the colon, for this example. So not all the products containing a substance would be helpful if they are not capable of delivering the substance where it's needed, for example, in this case. Also, another thing that is very important are the carriers that are contained in any really gut health products, because consumers that needs supplementation for gut health, they commonly have other issues related to gut health, like food intolerance, etc. So it is very important that carriers, or in the case if they have allergen, is free of allergen, all the carriers are suitable for the purpose of the product. So in the case of Butycaps from Optim, the dosage of butyrate is in the form of a butyrate triglyceride is 900 milligrams per sachet. There are 60 sachets, and the delivery technology is one of the key things of the product, because being 100% fat product, free of allergens, and what is important is that this butyrate is delivered in the colon, is delivered where it's needed, and this microencapsulation technology is what makes it suitable. So yeah, so that's what I wanted to talk to you about today, about butyrate as a short chain fatty acids, its relation to the gut microbiota and the gut health mainly. So thank you all for listening, and Benoit.
Thank you very much, Maria Eugenia, for this very detailed presentation on the short chain fatty acids and mainly butyrate. We can, I see that so far we don't have questions yet, but feel free to ask questions through the webinar interface. You can ask any questions. I think one thing that I didn't mention when we started the presentation is that both Maria Eugenia and David founded Elie Health Solutions. It's a company based in Sevilla in Spain. And about 3 years ago, they developed Butycaps, which is the micro-encapsulated tributyrin. And tributyrin is a triglyceride that would provide 3 molecules of butyrate. So they really found a very smart way to deliver butyrate in the colon. And as Maria Eugenia really explained, I think that butyrate has many benefits, and it's really, I think a unique and innovative product today that you have developed and that we are basically distributing mainly in Belgium. I don't know if David or Maria Eugenia, you want to add something on what I've said or what you said so far.
Yeah. The thing with the microencapsulation is to make sure that this butyrate triglyceride is delivered in the intestine, is delivered in the colon, because it's really where it's needed. And this is one of the biggest challenges to make a product like this. But also there's another challenge, that is the smell of it, the smell and the taste of it. As I was saying at the beginning, the butyrate is released, for example, in butter, when the butter is getting old, when the butter is getting bad, it's gone bad. So that smell is a rancid smell. It's a not very nice smell. It's very unpleasant smell of the substance. So another thing that is very important in the development of this kind of product is that you achieve an organoleptic characteristics that are suitable for human consumption, because that's as well as this is a very important thing for patient adherence.
And Maria Eugenia, if you had to summarize, the key benefits of butyrate and maybe how a practitioner can recommend or prescribe butyrate or Butycaps, what would be the 3 or 4 main benefits? And obviously, this is a food supplement. So what about, for instance, the intestinal transit, constipation? We have a question on constipations. So what would be the 3-4 key benefits?
Yeah. Constipation is one of the most obvious conditions where you can use butyrate. There are plenty of science related to that, and this microencapsulation really works very well for constipation condition. Also different symptoms relating to IBS, like bloating and and that kind of issues are also a good recommendation for this kind of product. And then what we find is this butyrate in this form can be used as the nutrition therapy for in combination for other drugs being taken by the patient in this case. So this would be a case or where you need to find a lot higher amount of butyrate than the amount you can get by eating more fiber in your diet, or if you cannot have fiber because of your intolerance. That would be a huge amount of butyrate that you're not going to be able to get by diet. Also, conditions related to the permeability status are nowadays the one of the most famous indication, like leaky gut and anything related really to high permeability status in the gut.
So it could be a good way to start instead of maybe providing directly, fibers in the diet, increasing the amount of fiber in the diet. You could start with Butycaps or the Butyrate to modify also the microbiota, and then add or increase the amount of fiber in the diet. Maybe to improve also the intestinal comfort of the patients.
Yeah, the thing with fiber is hard to increase the amount of fiber in diet, but also there are other situations, like for example, people that need to stay in bed. They have they may have problems with constipation as well, and this kind of product, because it's 100% fat, there's no fiber in it, is a lot more suitable for this type of consumers.
We have a question regarding the candidos.
Regarding what? Sorry.
Let me check. That's a French candidos. Yes. Yeah. That's.
Candidiosis.
Yeah.
Candidiosis. In the small intestine. The small intestine. SIBO?
Yeah, that could be. Yeah, there are other indications not related to the colon, but related to the small intestine, like SIBO, like it's called how do you say that in English? Overgrowth of bacteria in the small intestines. And this is another case where butyrate and butyrate triglycerides like tributyrin can be used to fight these SIBO issues in this overgrowth of bacteria like Candida. I don't know if the question was pointed that way.
There is a question regarding the organoleptic characteristic of butyrate. I know that you mentioned it. Maybe can you summarize quickly?
Yeah. Okay. So yeah.
Eugenia, the question is, I think it's different in salt butyric or sursine acid in salt form or ester form.
Yeah. You can find different butyrate products in the market, but most of them are in a salt form that you can find, like for example, sodium butyrate or calcium butyrate. And the smell of the salt is very strong smell of butyric acid. Butyric acid has the typical smell of vomit, for example. So it's a very unpleasant smell. On the other hand, you can have butyrate as an ester, as a triglyceride. And this smell is much better for this type of product, but also it is convenient to have microencapsulations and work on the aromas to have a more pleasant smell of the final product. So microencapsulation is also helping to the organoleptic characteristics of the final product.
And there is a question following what you've just said, Maria Eugenia. How do you know that it actually reaches the colon?
Well, triglycerides are broke by lipase, by the enzyme lipase. So that's one of the reasons any triglyceride really would bypass the stomach. So the first release, the first digestion of this fat would start in the small intestine. But also these microencapsulations, what they do is to make the release of the tributyrin and the butyrate to be slower and gradual, because these microencapsulations work in layers. So you have like if you can think of an onion, you will have different layers of this fat, and the lipase would act on the first layers, and then this granule, because they're like a granule, they would be traveling along the intestine, and they would be break by these enzymes along the intestines.
There is also a question regarding, that's a very technical one, but I'm gonna read it, and I'm sure you will be able to answer. I think of, when I consider postbiotics, I think of a molecule like comendamide, which is a long-chain acylamide made by bacteroid species that appears to be involved in cholesterol solubilization. Do you see MCFAs, so mid-chain fatty acids and long-chain fatty acids, as primary or at least key postbiotics? Or are there other molecules that you would consider more prevalent or important?
Yes, yeah, there are many. We're talking today mainly about butyrate, but there are other amino acids, there are other vitamins, there are other postbiotic substances that are produced by the gut microbiota. So this, and they would have an effect on the host. So they would be considered also postbiotic molecules, of course. But they need to be produced by the gut microbiota, and they need to have an effect on the host health. So that's two of the conditions that a postbiotic must match to be considered as a postbiotic molecule.
And the peptide of the hypertension, Maria Eugenia, is a postbiotic, very scientific studies. And
what was the name of this peptide?
IPP y VPP, valina, prolina, and isoleucina, prolina.
Yeah, this gut bacteria are also capable of producing some peptides that are related to hypertension, and yeah, this molecule will be postbiotic molecules as well, and have a completely different action that is not even in the gut. It's related to the arterial pressure. So yeah, absolutely, there are plenty of other molecules that can be considered postbiotics.
And another last question is, do you know how much butyrate or butyric acid there is in ghee? What's the percentage? I know that in butter it's what, 3 to 5%, but in ghee?
I am not sure actually. What I've read about is there are different techniques to make this traditional way of making ghee that are more effective for the concentration and the production of butyrate. but I'm not sure of the quantity, I have to say.
3-4% approx.
That's for butter.
Yeah,
That's for,
I think
that's
you
for
like
butter.
butter. Yeah.
Medium.
Yeah.
It's difficult.
We don't have any more questions, so I would like to thank you both, Maria Eugenia and David, for joining us today and talking about the benefits of short-chain fatty acids and mainly butyrate. And I would like also to thank you, everyone, for joining today and for your interest. Obviously, feel free to contact us should you need any information or any more information, by mail or on the website. You can contact us at info@laboratoire-optim.com or on our website, laboratoire-optim.com. So thank you again, and goodbye. Have a good evening. Thank you.